Picture yourself wandering through the awe-inspiring wilderness of Yellowstone National Park, geysers shooting skyward in dazzling displays, herds of bison and elk grazing quietly, and the crisp air filled with the aroma of pine needles and earth. It's a place that feels eternal, shielded from the turmoil of the modern world. Now, imagine the ground suddenly tearing open. A colossal crack, 100 feet across, slicing deep into the earth and shattering the peaceful scenery in an instant. This isn't a scene from a Hollywood blockbuster. It's a scenario that stirs our deepest anxieties about the immense, unseen forces lurking beneath Yellowstone. News of such a dramatic event would dominate headlines worldwide, with media outlets and experts racing to make sense of what's happening. The burning question: is the supervolcano beneath Yellowstone stirring, hinting at a possible disaster? Yellowstone isn't just any volcano. It's a supervolcano, among the most powerful on the planet, with the potential to unleash eruptions that could reshape life as we know it. Any sudden dramatic change on the surface, like a massive chasm appearing, demands immediate attention from scientists and the public alike. The land here is always in motion, floating atop a sea of molten rock. Sometimes, it reveals its secrets through bubbling mud pots, steaming vents, or unexpected cracks. These phenomena remind us that Earth is alive, unpredictable, and sometimes violent, capable of sudden, dramatic transformations. When a new fissure appears, scientists leap into action, using satellites, seismometers, and ground-penetrating radar to uncover what's happening below. They study the crack up close, gather soil and gas samples, and analyze every detail to determine if it's just routine ground movement or a sign of something more serious. While sensational headlines may spark fear, scientists work patiently and thoroughly, sorting through the evidence to reveal the truth. Even a massive crack doesn't automatically signal an impending eruption. Yellowstone has a long history of shifting and changing without erupting. The crust here moves for many reasons: hydrothermal activity, shifting faults, or the lingering effects of ancient earthquakes. Each shift is part of a story millions of years in the making. Our role is to pay attention to the planet and trust the experts who study it, not to panic at every alarming headline. Yellowstone's story is still unfolding, and science is our compass. To truly understand Yellowstone's importance, you have to look beneath the surface. Located mostly in Wyoming, Yellowstone is not only the world's first national park, but it also sits atop one of the planet's most powerful volcanic systems. The park's famous geysers and hot springs are just the visible signs of immense heat churning below. Yellowstone itself is a giant caldera, the result of a massive super eruption in the distant past. Unlike the typical cone-shaped volcano, Yellowstone is a vast network of magma chambers and shifting faults. Its energy comes from a deep, unmoving hotspot in the mantle, while the North American plate slowly moves above it. Over time, this hotspot has left a trail of calderas, with Yellowstone being the latest in the chain. Scientists from around the globe monitor Yellowstone, using it as a natural laboratory to study volcanic processes. Yellowstone is more than a national park. It's a rare glimpse into the dynamic forces shaping our planet. The term supervolcano might sound like it belongs in a blockbuster movie, evoking visions of world-ending eruptions and widespread devastation. In truth, it's a scientific label used by geologists to identify one of the most formidable natural phenomena on our planet. A supervolcano can erupt with a force thousands of times greater than ordinary volcanoes, spewing over 1,000 cubic kilometers of ash, rock, and gas, enough to cover continents and disrupt the global climate for years. Unlike the familiar cone-shaped volcanoes that build up mountains, these colossal eruptions are so intense they cause the ground to cave in, forming enormous, sunken calderas that can span dozens of miles. To give you an idea, Yellowstone's last super eruption, which took place around 640,000 years ago, was so massive it made the 1980 Mount St. Helens eruption look tiny by comparison. Fortunately, these catastrophic eruptions are incredibly uncommon. Supervolcanoes tend to erupt only once every 100,000 years or more, making them among the rarest disasters on Earth. Yellowstone itself has seen 3 major super eruptions throughout its ancient past, each separated by hundreds of thousands of years, leaving behind a landscape forever changed by fire and time. The volcano operates on timescales that are almost beyond human understanding, with cycles that stretch far longer than any written record. Which brings us to the big question: what would it actually take to awaken this slumbering giant beneath our feet? Deep below Yellowstone lies a vast, intricate, and partially molten magma chamber. Not a simple ticking time bomb, but a dynamic system that evolves over thousands of years. For a super eruption to happen, a huge surge of new magma would need to enter the chamber, slowly increasing pressure over decades or even centuries. This buildup would produce unmistakable warning signs, like significant ground swelling, clusters of earthquakes, and shifts in geothermal activity, alerting scientists and the public to the rising danger. Today, expert teams keep a close watch on these indicators, using advanced technology to spot even the slightest changes, so they can assess any real threat of eruption. For now, the supervolcano beneath Yellowstone remains calm, a sleeping giant, vigilantly observed, but at rest for the foreseeable future. Volcanoes communicate through visible changes. Cracks and fissures are part of how they talk to us. But not every crack signals danger. Many are simply the result of shifting ground or hydrothermal processes, not magma on the move. Yellowstone sits in a geologically active zone, so deep fractures and faults are a natural part of the landscape. Experts examine where a crack appears, how deep it goes, and any seismic signals to figure out what's really happening. The real warning signs come when cracks are linked to rising magma, accompanied by ground swelling and unusual gas releases. If there's just one big crack but no other red flags, it's usually just surface movement. The Yellowstone Volcano Observatory keeps a close watch, separating routine changes from genuine threats. Most cracks are simply evidence of an active Earth, not warnings of an impending eruption. Vigilant monitoring remains our strongest safeguard. Whenever something unusual happens at Yellowstone, the media often amplifies the drama. Sensational headlines with words like supervolcano and disaster can make the situation seem far more urgent or threatening than it actually is. This kind of reporting can spark unnecessary fear, especially when dramatic footage of geysers or bubbling hot springs is shown without proper context. That's why it's important to rely on scientists, the people who study Yellowstone's geology every day. These experts spend years investigating the park's underground mysteries, using cutting-edge tools and extensive fieldwork to separate real risks from myths. According to the majority of geologists and volcanologists, the odds of a super eruption at Yellowstone happening in our lifetimes are extremely low. The scientific evidence just doesn't support the idea of an impending catastrophe, no matter what some headlines claim. The U.S. Geological Survey and the Yellowstone Volcano Observatory keep a constant watch on the area, using a sophisticated network of sensors and satellites to monitor every tremor, gas release, and temperature shift. Their round-the-clock surveillance means any unusual activity would be spotted right away. The minor ground movements, earthquake clusters, and new surface cracks we see today are all typical for an active volcanic region like Yellowstone. These small changes have been recorded for decades and show no signs of intensifying. For a super eruption to occur, there would need to be a huge surge of fresh magma into the underground chamber, creating clear warning signs that scientists are trained to detect, like major shifts in seismic activity and ground swelling. We'd notice significant ground uplift, intense earthquake swarms, and big changes in gas emissions, none of which are happening now. The landscape is steady, and all monitoring data points to a calm system. The most probable future events at Yellowstone are minor hydrothermal blasts or slow lava flows, not a world-ending eruption. These are much less hazardous and are simply part of the park's ongoing natural activity. Such smaller eruptions have occurred many times throughout Yellowstone's past and are a normal part of the volcano's life. They provide valuable data for scientists and help refine future forecasts. The scientific community is transparent. The evidence shows Yellowstone is currently quiet. Experts regularly share their findings with the public, offering updates and answering questions to keep everyone in the loop. It's science, not rumors, that should shape our understanding. By trusting the experts and following credible updates, we can stay aware of Yellowstone's real risks without falling into unnecessary worry. Although a super eruption is highly improbable, it's important to grasp what such an event could mean. In the event of a massive Yellowstone eruption, the immediate region would be overwhelmed by pyroclastic flows and thick layers of ash. Ash would blanket much of North America, severely impacting farming, water resources, and essential infrastructure. On a global scale, sulfur dioxide in the atmosphere would create a haze, blocking sunlight and triggering a volcanic winter with cooler temperatures. This would likely lead to food shortages and major disruptions to ecosystems. These scenarios represent the most extreme outcomes, based on scientific models and geological records. Since humanity has never experienced a super eruption, scientists study these possibilities to inform and protect us, not to cause alarm. Ongoing scientific monitoring is essential for providing early warnings and building resilience. By understanding these rare risks, we can better prepare for even the most unlikely disasters. The sheer force of a supervolcano can seem overwhelming, but we're far from powerless. Yellowstone is under constant, expert surveillance. Researchers deploy seismometers, GPS systems, and satellite radar, along with gas sensors, to monitor every shift and change. Thanks to this careful observation, a major eruption would come with plenty of notice, potentially weeks, months, or even years ahead. Early warnings give us time to get ready and take action. Staying updated through trusted sources like the USGS is essential. Having basic emergency plans is smart for everyone, not just those living near volcanoes. We can appreciate Yellowstone's might, knowing that science is keeping watch. Knowledge is our strongest shield, far more powerful than fear.